All right, we're going to be going over questions 7 through 12 in this video. So for question number 7, what it says is that we have a regular pyramid that has side measures of 6, and we have a nice little altitude that measures 12. All right, well, that's enough information to find the volume. And just so you know, this is a level 10 question, level 10, where we learned about 3D shapes. Now for this one, we're going to go look at our formula sheet, which is given on the Regents, and it tells us how to find the volume of a pyramid. And it'll tell us that it says 1/3 the base times the height. Now let's be clear here. Base always means, we've said this once or twice, area of base. Always. Got to find the area of the base to get this problem done. So what we're going to do is draw the base. That base is a square. How do I know it's a square? It tells us that. It has sides of 6 and 6. So the area is going to be 6 times 6, which is 36. So that is my base, the area of my base. Now you just plug it on in. Volume is equal to 1/3 the base times the height, which is 12. So the volume is equal to, put that all in your calculator, you get 144 inches cubed. Done and done. All right, moving on to the next problem. This one, straight up, this is level 1, identifying transformations. I'll put it there, level 1, transformations. And the big thing when you're doing identifying transformations, remember, is making sure the right letters map onto each other. So you want to make sure that A maps onto D, E maps onto B, and C maps onto F. All right, so when you're like thinking about this, make sure that you get those right mappings here, okay? So let's start here. Let's just say a few of these that aren't going to work, okay? I don't know, which ones of these makes the least amount of sense? I would say a rotation of, no, these are all pretty good. These are all pretty good, all right? I can almost understand any of these answers. So let me just be clear what the answer actually is here. The answer is going to be number 1. Now, why? Well, you could actually do this reflection. So you can count, remember, when you reflect over the x-axis, you just count. So this is 2 down and then 2 more. So this is going to be D prime. E is 3. 1, 2, 3. 1, 2, 3. That's E prime. And then we have F prime. If you count it out, it's going to end up right over here. Alrighty then. Oh, that's in the wrong place, right here. So now that's your first one, a reflection over the x-axis. Then you do a reflection over the y-axis, which is this axis right here. And sure enough, if you reflect over this axis, everything matches up perfectly. A is going to map onto D, which we said has to happen. E is going to match onto B, which we said we want to happen. And F maps onto C. So it's number 1. All our points map on perfectly there. Okay, number 9. This is literally just memorizing a formula. Well, what is all this crap? Okay, so this is from level 6, where you learned about trig. There's 2 formulas you need to know. The first one is the sine of A is equal to the cosine of B when we have to know A plus B equals 90. That's important. And then the tangent, not the tangent, the follow-up to that is the sine of A is equal to the cosine of 90 minus A. All right? So those are the things you got to know, the formulas you have to learn from that level. Now, this is, in triangle ABC, the complement of B is A. So we know A and B add up to 90. Great. That's what complement means. Which statement is always true? Well, if A plus B equals 90, then the sine of A equals the cosine of B. Done and done. Question number 10. It says a line that passes through the points whose coordinates are 1, 1, and 5, 7 is dilated by scale factor 3 and centered at the origin. The image of the line is, and this doesn't even ask us to do any math really, it's just asking us facts. Is it perpendicular to the original line? Is it parallel to the original line? Does it pass through the origin? Or is it exactly the same as the original line? So this is what you should recall. In level 1, we learned about dilations. And a big fact about dilations, and there are many, is that dilations create parallel lines, otherwise known as slope stays the same. Slope stays the same. Now, if we know that the slope stays the same or it creates parallel lines, this question is just number 2. Nice and easy. Nothing for you to do there. Number 11, quadrilateral ABCD is graphed on the set of axes below. When ABCD is rotated 90 degrees counterclockwise, direction about the origin, its image is quadrilateral A prime, B prime, C prime. So it's going this way, 90 degrees. Great. Is distance preserved under this rotation, and which coordinates are correct for the given vertex. All right, so you just gotta say, is distance preserved, and then write the new coordinates. So this is from level 1. Coordinate. What am I talking about? Level 1 is transformations, losing it. Okay. So, first of all, let's answer the first question. Is distance preserved? That's another way of asking this. Is this a rigid motion? Is this a rigid motion? And let me just tell you this. Rotations are definitely rigid motions. Remember, rotations, reflections, translation, all rigid motions, dilations, not rigid motions. They don't preserve the size and shape, or in other words, they don't preserve the distance between points. So yes, this is definitely a rigid motion. 1 and 2, you're out. And now we just got to figure out which point would be correctly rotated. So B is at 4, 3, and A is at -2, 6. Now, to do a rotation of 90 degrees, rotation of 90 degrees, just to tell you the formula, it's x comma y turns into -yx. All right? So let's write down those 2 points. We got B is 4, 3, and we have A is -2, 6. Now, if we were to use this transformation, that means you flip it and you change the first thing. So we're going to flip it and change the first one. So we would get -3, 4. See how I flipped it and I changed the first one? And this one, I would get -6, -2. All right? So, which one of these points is correct? Well, I think it's clear here. It's going to be B. That is the correct point. A, totally wrong. And let's also just think about this logically, because you could do this without doing a lot of math. B would be, it's telling us B would be at -3, 4 after rotation 90 degrees. That sounds about right to me, right? That moved over 1 quadrant. Now A would be at 6, 2. For A to go counterclockwise to 6, 2, that would be 270 degrees. Like so far off. That is wrong. And now for question number 12. This one's a little tough. Now, this one says, in the diagram below of circle O, the area of the shaded sector is 2 pi centimeters squared. So this shaded sector is 2 pi. And we also know the length of NL, which is this whole thing right here, is 6. So let's label that. We want to find the measure of angle N. Let me just say, this question is hard, all right? So this is, first of all, from level 9. Level 9, where we learned about circles. If you really want to look into this, this is from 9.4, we learned about the area of sectors. Now, what we're going to do here is find the area of this shaded sector first. We're going to use that formula to find this angle. All right, I'll show you how. So if we know that this question says the area of a shaded sector, the first thing I'm going to do is write down the area of a shaded sector formula, which is pi r squared, remember that's the area formula, plus this guy theta over 360. Now, I know 2 things. Remember, there's 3 variables here. There's area, there's your angle, and there's radius. All right, so there's 3 variables here, really, not just 2. And I know 2 of these variables. I know the area is 2 pi, that's given to me, so I'm going to write 2 pi is equal to. I don't know the angle, so that's x over 360. And know the radius here is not 6, but it's actually 3, right? So it's 3 squared. So what we're going to do here is solve for our angle. And you guys should know this by this point. This is multiply by 360 and cancel out your pi's. So the pi's cancel out, you multiply both sides by 360. By doing that, these two 360 cancel out on the right side of the equation, and you get 720 on the other side. So we get 720 is equal to, well, 3 squared times x is 9x. All right, divide both sides by 9, and what you would get is, let's see, 720 divided by 9. We get 80. So 80 degrees is equal to our x. So bear with me, that is not the answer. I'm not going to circle this yet because, check this out, what you've actually just found is this. You found your central angle of 80 degrees. That means our arc is also 80 degrees because central angles equal arcs, and that means n is 40 degrees because your inscribed angle is half the arc. That's a hell of a question. That's a good point to end this video. Peace out. Kiss your mama. Ooh.